Okay, good morning. Our topic for today is dryer and drying process and calculations. And I'm giving commendations sa nag-report. No? Maayos naman yung report. Mga iba't ibang klase ng dryer, pero kulang daw ng calculations. And then we are going to discuss yung calculations. No? Pero bang may, pero bang ano? Pero bang nag-ano? Every time na nakakarinig ako ng sound, ayoko may kung may admit no ayoko may naghihintay no sa labas ng meeting gusto ko lahat makinig. So gusto ko pag nag-start tuloy-tuloy kasi kung laging may nagpapa-admit na magugulo ating yung ating lecture process, di ba? Every time may turbo. So ganun 'yon. So we're gonna start sa dryer, no, and particularly focus tayo sa drying process. The first question is, kayo ba ay nag-air conditioning na? Tapos na ba sa air conditioning? O sagot. Tapos na ba yung subject na air conditioning?
Yes po.
Tapos
Yes
na,
po.
no? So ibig sabihin yung andun, yung refrigeration tsaka air conditioning is magka-related naman yan. So kung tapos na yon, sa air conditioning, meron tong portion na dryer, no? Pag inaral nyo pag tiningnan nyo yung syllabus ng air conditioning, meron dong dryer, no? Kaya lang siguro sa haba ng mga topics, no, hindi na di-discuss yung portion na dryer at yun ang ating i-discuss sa ngayon. Ngayon, ito ay mga iba't ibang problem sa board exam ng Pilipinas, no? At yun ang ating titake upin, di ba? Siyempre, pag sa mga board exam, nandyan din yung combination ng mga refrigeration tsaka air conditioning, diba? So, yan yun. I want to discuss simple muna, no? Simple problem para hindi naman tayo bigla. Kapayata nga sa to. Wala mo nang hindi mo na ginagamitan ng chart, no? Hindi mo na ginagamitan ng chart mo. Mga chart na kasi to, no? Natin to. Hindi mo na ako nakita. So we're gonna start here muna sa pinaka-basic, no? Pag pinag-uusapan yung dryer, no? Sa Tagalog class, ang dryer ay tungkol sa pagpapatuyo, di ba? Drying. So when you talk about drying, hindi mo mayaalis. You cannot take away another concept, another word, which is associated in drying. Ano yun? Nag-uusapan yung dry, how much dry, how dry, ano yung isa na dapat nating maintindihan na konsepto. Ah, ang sagot. Ang sagot?
Sir,
Ah,
try ko lang po.
sige, try.
Moisture content po.
Very good. Moisture content. Ano yung moisture content? Paano sinusukat yung moisture content? Ha? Nasaan ba yung moisture content? Konsepto ng moisture content. Tama yan, no? Moisture. Mahalaga ba talaga ang moisture content? Anong sagot?
Yes po.
Bakit?
Kasi po sa drying process, yun po yung moisture content po yung nagdadagdag ng weight ng material. Therefore, yung purpose ng drying process aside from yung may removing moisture in turn would remove weight po dun sa material natin pong i-dry.
Very good. Thank you. Very good. Kasi ang dryness ay ipapaliwanag sa konsepto ng moisture content. Tama? So, gaano ang natitirang basa? Gaano ang natitirang moisture doon sa tinatawag na bagay? Linawin natin yan. Kung gaano kahalaga ang pagpapatuyo, ay ganoon din kahalaga yung natitirang basa, no? Otherwise, gusto mong mabuhay sa isang mundo na dalawa lang, no? 100% wet or 100% dry, di ba? So, kung ikaw ay nag-take up na ng natawag na refrigeration, maaalala mo na ang chart na ginagamit sa refrigeration, very familiar sa refrigeration ay pH diagram. Ano ang pH? Ang P ay tumatayo o nire-represent ng pressure at ito naman ay enthalpy. Ngayon, kadalasan ang pH ay parang dome o parang bell na may mga parts. Paliwanag ko lang yung dry. No? Sa gitna ng pH na to ay tinatawag na critical point. Ano yung critical point? Hindi mo na malaman, very hard for anybody to distinguish kung ito ay basa o tuyo. No? Critical point. Yun. Ibig sabihin, nadi-divide siya sa dalawang parte o kalahati doon sa left half and right half. Sa refrigeration, related to refrigeration, drying, tsaka air conditioning. Kung ang iyong mga parameters ay nandito sa left half, ikaw ay nasa liquid type. Anong klaseng liquid? Saturated. Kung ikaw naman o yung mga data points mo ay nagpo-fall dito sa kalahati na ito ay saturated pa rin. Anong klaseng saturated? Saturated vapor. Kaya, ang mga subscript dito sa kalahati na bandang kanan ay ganito, no? Volume of gas, entropy of gas, enthalpy of gas. So, yung gas, yung vapor. So, ibig sabihin, dito, 100% dry. Kaya tayo ay related sa ating paksa or topic na dryer. Yan. Kung dito ka naman sa kalahati, let me change the color of our pen, digital pad. Dito ka naman, if your parameters is falling here, ikaw ay nasa liquid. Ibig sabihin dito, zero ang dryness. Diba? Dito naman, zero ang wetness. No, kasi pure eh. Ito ay pure dry. Ito ay pure wet. Diba? Kaya nga, hanggang dun lang siya, no? Kumbaga, wala na siyang i-wet. Hindi na siya pwedeng mabasa, basang-basa na siya. Ito naman, hindi na siya pwedeng matuyo dahil 100% tuyo na siya or 100% dry. Yun yung sinasabi na saturated. Yun ang ibig sabihin ng saturated. Diba? So, ang mga subscript mo dito ay volume of fluid, entropy of the fluid, at enthalpy of fluid. O, paano na ngayon naman pumasok yung ating concept about moisture? Asan yung moisture dyan? Asan? Ha? Asaan? O, nasa na? Nasa na yung moisture content dyan? Ha? O, kaya sagot. Sabi tayo mga o 4C. 4C ba kayo? Nasaan pumapasok ang moisture content dito sa ganitong graph? So, ang sagot ay narito. Di ba? Ito ay ang iyong graph, di ba? Dito, no, in between the saturated gas and the saturated vapor, nandun yung mixture. Anong mixture? Mixture of what? Of refrigerant. Bakit refrigerant? Eh kasi nga pH 2, di ba? Refrigeration. Di ba? Ganun yun. Kaya ang tinatawag dito ay gitna na ito ay dryness fraction or yung X, di ba? So dumako naman tayo sa steam, no? Pag yung steam, ano lang kunin na para meron tayong pagsasalatan. Yung TS naman, no? TS diagram, di ba sa steam power plant or Rankine, ang kadalasan na ginagamit ay TS. Yan. Diba? So yung TS, diba? So yung TS, so, yung part niyan ay saturated liquid tsaka saturated na steam. Ganun yung dryness. Yung nasa dry, 100% dry. Di ba? 100% dry. At in between, nandun yung X, which is dryness fraction. Yan. Pag nandito ka, malamang 50. Malapit ka dito, mga 97, 99, di ba? Ito, mga 10, 25, o dito, wet. So, doon pumapasok yun. Hindi mo maipapaliwanag ang dryness kung walang moisture content. Gaano ba kahalaga ang dryness or moisture content? Napakahalaga niya, class. For example, bibigyan ko kayo ng example. Dito na lang, no? Ang staple food ng Pilipinas ay ano? Ano ba yung staple food ng Pilipinas? Oh, hindi na alam. Ano yung staple food? Ano ang pambansang pagkain ng Pilipinas? Ano ang pambansang pagkain sa Pilipinas? Gerald, rice, tama. No? So, rice, no? So, yung rice na yan, ang rice na yan, di ba, aanihin mo yan, no? So, our staple food is rice. And our subject is manufacturing industrial plant process with plant visit. So, later on, pag may time tayo, aralin natin itong paano magiging rice mula sa palay. No? Our term is palay, papuntang rice. Bakit na-involve ang dryer dyan? Kasi, ang mga palay, pag inani mo yan, ay may basa-basa content in terms of percentage. At alam mo ba, whether rice, no? Second to rice is corn, yung mga maize, di ba? Second to rice is corn or yung maize. Alam mo ba, mapa-rice, mapa-corn, mapa-munggo or kung ano-ano man, lahat ng yan ay may moisture content. At lahat ng yan ay may parameter na tama bago ka mag-umpisa ng mga process. Our subject is industrial, no? Manufacturing and industrial process. So we have to know that once we harvested the palay, ano yung mga moisture content? At ano yung ideal moisture content para siya ay gilingin, milling. No? Sa rice ay kono. Yan nyo ba kung bakit kono ang tawag? Kasi ang popular na rice mill, kono, wala pa yung mga digital and other batch and so on. So, ang mga modern na rice milling, cone rice mill. Diba yung cone na yun? Kono, may ganyan, di ba? Kono. Kono, cone rice mill. Para naman makinabang tayo sa internet kasi tayo ay online na na pag-aano, pagtuturo o patanungin natin si Google sa artificial intelligence na what is the ideal moisture content of rice for milling. Tinatanong ko si Google, ano ang ideal moisture content ng rice before milling? Kasi sa mga mais, I think sa mais, mga 11 to 14 percent moisture content. Ito lang na alala sa rice. Tingnan natin. Oh, pakibasa mo nga. Sino babasa? Pakibasa mo nga. Good kanina. Pakibasa mo nga. Sino magbabasa? Oh, Gerald.
Sir, ako na, ay,
Sino?
sige po.
Sino ikaw? Sino? Ano ba tayo? Ayan. Pakibasa mo nga.
Sir, ideally, rice is dried to 12 to 14% before being milled. If the grain intended for storage, then its moisture content is further reduced to as low as 9%.
Okay, very good. Mahalaga ba? Nakikita ba ang kahalagahan ng moisture content? Mahalaga ang moisture content, ang kaalaman sa moisture content or dryness. Dahil sa particular na grain, katulad ng rice, ang sabi dyan, ideally 12 to 14. Di ba sabi ko nga 11 to 14 sa mais, no? So sa rice, 12 to 14. Ngayon, babawasan mo yung moisture content, gagawin mo siyang mas dry kung ang intention mo ay ilalagay yan sa storage, no? Sa mga malalaking, 'di ba, yung warehouse. Siyempre dapat mas dry, mas less ang moisture content kasi ang moisture content yan ang hinahanap ng mga insekto, 'di ba? Mga bukbok, 'di ba? Mga insekto, mga bukbok, mga kung ano-ano pang mga hindi natin alam yung pangalan ng mga ng mga insekto na nandoon. Kasi pag basa-basa, 'di ba? Gustong-gusto 'yan. Ngayon, tingnan natin. What is the ideal moisture content of rice? Ito naman, maize, corn. Pakibasa mo uli. Pakibasa.
Corn, according to the channel.com agronomics site, the ideal time to harvest corn is when it is between 22 to 25% moisture content.
Di ba? Mas mataas, no? Yung iba naman mga 15 to 18, no? Depende sa reference. Ang kinote niya dito ay channel.com, no? So, kasi ano lang naman to, sinerch lang naman natin, no? How dry should be a corn when harvested? What is considered high moisture, di ba? How is moisture content related to milling? Ayan, oh. Meron ba? Meron bang kaugnayan o correlation? What's the correlation between moisture content and milling? The one that we have talked about a while ago is harvest, no? Pupunta ka dun sa plantasyon ng corn, titingnan mo yung moisture content. Pag 22 hanggang 25, pwede na yon, di ba? Pero ito naman, related ang moisture content or dryness doon sa milling. Kailan mo siya dapat gilingin? Ang gilingin, alisin mo yung corn na mga balat, di ba, yung balat, at alisin mo yung corn cob, di ba, corn cob. Di ba? Kasi di ba may balat yon, tawag doon ay husk. Alisin mo yon. Tapos corn cob, di ba? Tsaka yung corn, kernel. Kernel, yung mga butil-butil. Corn cob, yung mga pusal, yung one. Sabi dyan, for milling, the ideal moisture content is between 13 to 14. Di ba sabi ko nga sa inyo kanina, mga 11 to 14 according to research, because when I was lecturing in Africa, no, sa university ko, meron akong ginawa ng corn milling machine, no, high capacity corn milling machine. And according to our research, eto nga, mga 12 to 14, 11 to 14, depende sa mais, no? Field measurements also need to be corrected for a standardized moisture content of 14. So pag nasa 14 ka na, no, halos standardized na. Anong kinalaman ng milling doon sa moisture content? Kasi pag sobrang sobrang basa, hindi maganda ang pag-mill. Pag sobrang tuyo, hindi rin maganda kasi bibitak, no? Mabibiyak yung mga ano. So yung efficiency mo, yung sa grain, the grain if milling efficiency pabawasan, no? Ito. Halimbawa, what moisture should be corn be stored at? No? So, anong moisture content mo dapat i-store ang corn? Ayan, no? It can be stored at 15.5. However, it will be stored for 6 to 12 months. No? Ating taon, ng isang taon, the moisture content should be reduced to 14. Di ba sabi ko nga sa inyo, the longer you intend store a certain grain product, the drier, or the dryness, the more dryness it have. Di ba? Kasi i-reduce mo ay ano mo nga, store mo, baka bukbukin yan o ng mga insekto. If the storage is a year or longer, mas mahaba, isang taon, the moisture content should be 13. Anong point ko? Gusto ko lang idiin yung kahalagahan ng moisture content. Kasi yung moisture content, yun ang pansukat sa dryness. Diba? Kapag ang iyong produkto ay zero moisture, o ibig sabihin 100% dry yun. Yung dryness, yung pagkabasa, yung amount of fluid or liquid na nandoon pa, na natira. Kung ang moisture content mo ay zero, ibig sabihin 100% dry ka, no? Dry na dry ka. Baka tulad nung binigay kong example sa 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 pH diagram, di ba? Kasi related naman lahat yan dryness yan di ba? So maliwanag na 'yon, no? Ngayon, may dryness, dry sa air conditioning, evaporator, sa air, refrigeration, no? Pero meron din sa dryness or dryers sa produkto, ba? So, yung sinasabi natin kanina, yung sa mga air conditioning, na-take up na natin yon kasi galing na tayo sa refrigeration at air conditioning, no? Ngayon, balikan muna natin yung sa air conditioning. Paano mo malalaman sa air conditioning ang dryness? Diba, binigyan ka ng problem. Anong chart ang gagamitin? Ha? Gerald? Anong chart ang ginagamit para malaman mo na gaano ka-dry o gaano ka-wet ang iyong hangin na sa ilalim mo sa air conditioning? Anong tawag sa chart na yon? Oh, graduate na ng di ba? Ng ref at aircon. Anong chart yon? Anong chart? Ano?
Psychrometric chart po, sir.
Oh, psychrometric chart. Yan, di ba? So, psychrometric chart, ang chart para malaman gaano ka-dry, gaano ka-wet, ilan yung relative humidity, no? Ano yung tinatawag na moisture content. So, meron dito, no? Ito na lang, pinakasimple. No? Psychrometric chart. Psychrometry, ang ibig sabihin niyan ay study of the moisture in the air. Di ba? Sabihin, ang psychrometry ay mga properties ng air. Di ba? So, kasama na yung brightness, kasama na yung density. I-review ko lang para, di ba, bago tayo mag-lab, bago tayo magtingin-tingin ng mga dryer dyan, ito, sabihin na natin, no? Ano ba ang mga property ng hangin pag ikaw ay nagdi-design ng isang lugar na i-aircon mo, no? Halimbawa, pwede mong kasing initin, halimbawa, kung nasa Baguio ka, Tagaytay, or nasa Scandinavian countries ka, or those countries that are having winter, no? Like Canada, Russia, di ba? US, di ba? Scandinavia, like yung mga Finland, di ba? Finland and malalamig, no? Finland, Denmark, Iceland, di ba? England, Ireland. So, yung mga yan, nagyayelo yan. So, ang conditioning mo doon ng air ay painitin. During winter, painitin. Di ba? During summer, kung gusto nila. Pero nung nasa, wala namang masyadong aircon sa, nung karal ako sa Germany, tsaka sa US, wala namang aircon yung, bahay. Kasi malamig nga. No? Ang meron lang sila heater. Kasi kailangan nila ng mainit pag nagmalamig, no? Eh, hindi na sila magmamalamig kasi hindi naman sobrang init doon. Gusto na nila init. So, ngayon, bakit na sama to sa dryer, no? Or sa problema ng dryness, no? May mga parts kasi to, no? Etong tawag dito ay yung temperature na sinusukat natin, mismong actual na temperature. Temperature natin, no? Halimbawa, temperature gun or thermometer, tawag dyan ay dry bulb. Merong isang temperature, tawag doon ay wet bulb. Ito, tanong. Alam mo ba kung nasaan yan? No? So, yung wet bulb temperature, ito. Yung pa-slant, ayun. Kapag kinuha mo yung mga slope na yan, na ganyan, no, ayan, no, mga wet bulb yan, no? Wet bulb. Halimbawa, ito, ano yan? Nandito yan, no? Sa 30. Ito, 20 degrees centigrade. Ito ba ay Fahrenheit or centigrade? Centigrade, no? Ito, ilan to? Gerald, ilang temperature to? Ha? Nakikita ba? Nakikita ba yung wet bulb, class? Wet bulb. Nakikita ba yung slide ko, Gerald? Ano ba yun? Kenneth, nakikita ba yung slide?
Yes po, sir. Kita po.
Oh, eto, di ba? So, nakita nyo yung no, yung dry bulb tsaka wet bulb. Ngayon, ang tanong ko, kailan mag-equal ang dry bulb tsaka wet bulb? Kailan? Ayon sa chart. Na-take up nyo ba yung dryer sa air conditioning? Hindi. Na-take up ba, Kenneth?
Yes po, sir.
Yung dryer? Nasagot, ano nyo, ano nyo, naabot nyo yung dryer?
Yes po, sir.
Oh, very good, no? Kasi sa iba hindi naabot eh. So, ang tanong, kailan ba nag-equal ang wet bulb at dry bulb? Kailan?
Kapag sa, saturated po yung condition.
Saturated, ito yun, tinan nyo. Ito, tong line na to, yan, yung pinakadulong line, yan yung line of saturated condition. Ano yun? 100% relative humidity. So, 100 yan. O, ito, pababa. No? Ang, halimbawa, ito, 90. O, itong 100% humidity, ito, 90, 70. So, related yan. Okay? Pero normally, mababa ang wet bulb. Diba? Mababa ang wet bulb. O, kasi ito, magiging 20 lang pag nandyan sa saturation. Diba? Eh, kung wala sa saturation, ito lang. Diba? Pag ito, baba. No? Ito 20. Edi, Yan, dito mababa. Okay? So ngayon, nasan yung ating mga ano diyan, no, yung sa dryness, no? Related kasi yung relative humidity ito, saka yung dryness. Related yan, no? Tapos ito naman, nasaan yung pinag-aaralan natin ng moisture content? Ito yun, no? Ano, grams of moisture per kilogram of dry air. Ito to. Kung nasa kanan ka, nandun yung tinatawag na specific humidity. Or another term is humidity ratio. You know, grams, diba? Nakita nyo, grams of moisture per kilogram. No? Grams of moisture per kilogram of dry air. Yan yun. Ito yun. No? Sa metric, meron din ganon. So, makikita mo siya na yung mga humidity, the amount of moisture in the air is nandito. Ito naman is yung relative humidity in terms of percent. So, pinakita ko lang na related ang dryness sa steam power plant, related ang dryness sa air conditioning, at related ang dryness sa refrigeration or yung sa vapor compression. So, punta na tayo dito sa dryers in terms of product. Ano nag-usasabi natin na nag-usapan natin na related sa product, sa produkto. Halimbawa, meron kang buhangin, meron kang furniture, meron kang natawag na mais, may bigas o anuman. So, ang ayan ay kailangan na malaman mo ang tinatawag na moisture content. Diba? So, ganito yon. Punta na tayo sa formula. No? Bago tayo pumunta sa formula, meron tayong, paliwanag ko lang yung dalawang type. No? So, halimbawa, ito ang iyong dryer. Ito yung dryer mo. Meron ka na type ng feed. No? Lahat ng pumapasok dyan na grain or mga produkto, ang tawag dyan ay feed. Pinifeed mo eh. Diba? Pag lumabas na, siyempre, nabawasan na ng moisture, product ang tawag. So sa engineering, para pasimplihin, mga bagay-bagay, yung mga parameters, ganun yun. No? Ito, product, feed, F. Diba? Sabi sabihin dito, sa feed side natin, mga side, no? Meron tinatawag na MC. Ano yung MC? Moisture content. Diba? Sa product, may moisture content din. Ano ang masabi mo sa moisture content ng product at ng feed? Siyempre, mas malaki. No? What we can say is, in the feed side, no, ito, sa feed side, diba? More or larger pa, no? Larger ang moisture content. Pag dito, no, yung mga parameters natin, we should expect or expectedly that once the drying process is being carried out, dito naman, in this case, less na ang moisture content. Diba? So, ano pang meron dyan? Yung tinatawag na feed rate o yung kilogram per hour, no? Yung mass flow rate. Yung mass flow rate, imbis na M, no? Sa formula, F, diba? Ito, moisture content of feed, diba? F na lang din yun. Ginagawang M. Bawa, moisture content of product, diba? So, P na lang yun. Kaya P. Diba? So, kilogram per hour yun. Maliwanag ba? So, ito, bawa, feed, kilogram per hour, 1 minus percent moisture content of the feed equals product in terms of kilogram per hour, 1 minus percent ng moisture content ng product. Okay? So, para maliwanag lang. No? Basta, ang pinag-uusapan natin, pag pumasok pa lang yung mga produkto, mas basa pa yan. Diba? Pag dito, output or discharge, diba? Yun ang mga term natin. Oh, ito yung sa dryer mismo, yung coil. Diba? Coil. Heating coil. or hangin or ano, basta may heat dyan, no? May heat dyan. Pag lumabas na doon, sabihin, mas less na yung moisture content. Yun ang ating intention. Okay? So, na-review ko lang. Ngayon, ano ba ang gusto nating take upin dito? Simple lang. May mga chart, no? Ito na lang una. Let us take up a certain problem, and it has to do with the dryer or drying of room. No? Ito dryer ng product, ha? Dryer ng room. Okay? O gusto nyo product muna? Ha? Dali. Ako nga, baka may video na tayo doon. Ha? Para, para kasi kapag ano tayo ng production. Punta muna tayo sa channel natin. Tingnan natin sa
Win.
dali.
Show me where to go.
Kasi nakikita na sample sa product eh. So, let me start, no? And then, pag may time pa, I'll be calling one of you para i-present 800 pounds of dry air. Ano yun? Per hour. Ano yun? Anong tawag doon? Dahil sa may product. Hello, good morning to all of you. To dry, you have to do... Ito. Para may basic tayo ng ano, na? Nakikita ba, class? Nakikita yung ano, screen?
Yes po, sir.
Sige. So, eto muna tayo. Before we go to the problems, let us review first about the dryers, dryer fundamentals and dryer formulas. So here is the basis for the ideal dryer, adiabatic. Adiabatic means there is no heat transfer, meaning there's no heat in or there's no heat out, meaning that the heat cannot go out or cannot comes in. Not so
Sir, nawala po yung audio.
dryer. So the schematic is like this. We have here at point 1, somewhere in point 1, there's a heater. And then after that, there is a fan. And after the fan, there's the dryer. So point 2 is the fan, and 3.
Opo, sir. Meron.
Hello, good morning to all of you. So to our viewers, to all the students, and the teachers who are watching our channel. So this time we are going to discuss the board examination solutions for dryer problems. We have started like days ago. We tackle one problem about the dryer, and this is just the continuation. So dryer board exam solutions. Before we go to the problems, let us review first about the dryers, dryer fundamentals and dryer formulas. So here is the basis for the Ideal dryer, adiabatic. Adiabatic means there is no heat transfer, meaning there's no heat in or there's no heat out, meaning that the heat cannot go out or cannot comes in. Not so adiabatic dryer. So the schematic is like this. We have here at point one, somewhere in point one, there's a heater. There's a heater, and then after that there is a fan, and after the fan there's this the dryer. So point two is the fan, and three is the dryer output or discharge. No, so here in the heater, there's a lot of media here or method. You can use steam. You can also use electric dryer, but others are using steam. So we have a mass of steam and enthalpy of steam. Here, because it's outside, there's a mass sub A, MA, a mass of dry air going to the heater, and here there is the HFS, and then here there is this dry bulb 1, then wet bulb 1, and relative humidity 1 at point 1. So here is the heater, and of course if you have a heater, there is a coil. Yeah? So the coil, the heating coil is here. If you are, yeah, yeah. So heating the heater coil is here, and if you are using steam, of course the steam is the one flowing into this tube, no, if you are using steam. Then here at point 2 is the location of the fan, and it will fan out air into this dryer. So this is the dryer, adiabatic dryer. So if this is dry bulb 1, so this is dry bulb 2, no, dry bulb 2. If this mass of A, mass sub A, so this mass sub A, because mass is just constant, no? So if it enters here, so there is this mass flow of air coming into the adiabatic dryer, and then when the dryer has already done its part or function. So here is the discharge at the point 3. So here we have mass A again, then dry bulb 3, relative humidity 3. Okay, now going back to the dryer, there is something else that is happening here, and it's about the feed and the product, because the dryer is just like a vessel, like a vessel that you have an input and then you have an output, but on the inside there is something happening now. You are trying to put here some materials. Now you are trying to feed some materials like maybe grains or palay or sand or copra or coconut wire or textile, whatever you want to dry, you have to load inside the dryer, and that is in general called feed. Yeah, so you are feeding a material, so in this direction, and then when it comes out, it is coming out as a product. So there are two sections here. One is feed and the other one is product. So here in the feed there is a moisture of feed, percent mm, percent moisture of the feed, and here is the percent moisture of the product. So from here we can infer, we can deduce, no? We can say that the moisture content at the feed is more compared to the moisture content at the product side, right? Because moisture content is, or the water vapor content is being extracted or released, and then it will become dry, or drier, more dry than the condition in the feed. No? So this schematic diagram helps us to at least imagine what is happening in the dryer. So these are the concerned parameters, no? And there are considerations in the dryer. So there are fundamental considerations, and these are as follows. Unless otherwise specified, drying operation is always adiabatic saturation. Now, so adiabatic saturation wherein wet bulb is constant. No? So adiabatic saturation. So in the psychrometric chart, no, psychrometric chart. So this is the psychrometric chart. No? So this one is heating. This one is cooling. Sensible heating, sensible cooling. Then this one is humidifying. No? This one is humidifying, the other one is dehumidifying. Now, in between, there are some processes that is involved. Now, where's this adiabatic saturation? So the adiabatic saturation is here now. So there's a you can project a line going like this, and then it is the adiabatic saturation where wet bulb is constant. So all the wet bulb temperature here is constant. Okay. So now, the dryer capacity is always referred to the product unless otherwise specified. So the capacity of the dryer cannot be measured in the feed, no, because nothing is happening, no, nothing drying is happening here, no. So the capacity is always at this side, no, at the product side, meaning after the dryer accomplish its function. Now, the dryer and product relationship is the one that is always being asked in many problems. For example, in the board exam, they always ask for dryer feed and product relationship. So we will discuss a bit later what is the relationship between the product and the feed, or feed and the product. Then another question is always being asked is the capacity of the fan in the dryer, meaning the capacity in terms of what meter cube per hour, liter per hour, or meter cube per hour. So that can be found if you can locate the specific volume of the fan, no, in the psychrometric chart also. Then the required heat of or steam flow input of the dryer. So what amount of heat is required to dry a material at this relative humidity or at this moisture content or percent moisture. So that amount of heat is always being asked in the board exam, because this is the review or practice in the board exam. So here, feed or product. As I told you, there are two sections in the dryer, and let me use this portion here. So here is the feed. When you try to have a feed, then you will have an output as the product. And each material, I mean, the material in each section has a percent moisture, percent moisture. So here at the product, there's a percent moisture, which is obviously lesser than the percent moisture in the feed. No? So the dry, I mean the dryness, or let us say the temperature of the feed should be lesser than the product. Yeah? So when after the dryer, it should be hotter, yeah, than the initial. When you try to first put the materials in the dryer, so it is not as hot as when it is coming out, right? Now, what is the general equation for the feed or the product that serves as a governing equation in the solving of problems in the field of air dryer? So here we have the principle of mass, and what kind of mass? The bone dry mass. So bone dry mass by principle in dryer is constant, meaning the mass that is coming in is the mass coming out. So how do we put that here? bone dry mass of feed, so meaning the mass of the feed equals mass of the product. No, but what kind of mass? It is bone dry. Bone dry. Yeah, bone dry of feed is bone dry of the product. Now, the general formula is this. Now, F, so F is quantity 1 minus percent MF equals P 1 minus percent M sub P. So what is F? F is mass flow rate, meaning the material that you are trying to feed or to put in the dryer can be can be measured in terms of kilogram because it's a rate mass flow rate. It could be kilogram per second or kilogram per hour, right? So those are the units. So and then if you are going to multiply with 1 minus percent MF, so it's just a number, no? So for example, 1 minus zero point 0.5 or zero point 0.9. So still it becomes the the kilogram per hour, no? So it will this unit will prevail. Same thing with the product. So the product has the unit of kilogram per minute or per hour or per second. So it is a mass over the time. Yeah, it's a rate of flow. So kilogram per hour, right? So times 1 minus percent MP, and then you will get the bone dry mass with respect to the product because on the left is the feed and on the right is the product, right? So that is our general equation, and on the subsequent or the following pages we are going to dissect, we are going to put into details or maybe so much detail about the equation. How did we arrive in the equation? So here is the derivation. Which derivation? This general formula here. Where did we get this? Now, so it's better for us to understand where is this derived or where is this coming from. That the of course it comes from the bone dry mass of feed equals bone dry mass of the product. Yeah. So here is the derivation, and we're going to discuss this, right? So here is the feed now. So there is this component of the feed, yeah, and feed. Now, so here is the mass flow of feed, and then this is the bone dry mass of feed. Now, mass of feed and bone dry mass of feed. That is the section wherein the feed is kind of decomposed into. You know? So I have here the whole feed. I have here the mass flow of feed, and I have here the bone dry mass of feed. Now this is the mass flow. This is the mass flow, and this is the bone dry mass of feed, no, BDM, right? So here, what about the feed? The feed is the total, yeah. So when we talk about feed, so it is the same as this. So MT total, yeah, total mass. The total mass that we are talking about is the mass flow of the feed and then the bone dry mass of the feed. So if we are going to put that into equation and do some kind of manipulation, so our feed is the MT, right? So this one is the total mass. So MF, this one, so MF plus bone dry mass of feed equals F. Now, F. But F is equals empty, right? F is feed equals total mass. So it's just this equation. So here is the mass flow, that one, plus bone dry mass of feed equals the feed here, right? So here is just the summation of this element and this element, right? So I think it's very clear, you know. So the total mass is the feed, then mass flow rate of the feed plus bone dry mass of the feed. So if we continue on the development of the equation, so percent MF, so how do we get the percent M? There's another equation given here, and it says percent MF. So how do we get the percent MF? So meaning percent of the mass flow is equal to MF over F, right? So MF over F. That is the percent. Now it's like this, yeah. So so this is the portion, the mass flow, and then this the total, right? The feed, or the this one, or the total mass. So if you get this, you will of course getting a smaller number. I mean a decimal number. So it is termed as percent MF, no? Percent MF of the feed. So meaning it's the percent moisture of the feed. So let me continue in this so that we can systematically tackle this topic. So percent MF, right, or here, this one, MF, the percent MF equals F minus BDM. What is F minus BDM? F minus BDM. This one, now from this equation, you can get the equation of MF here. Yeah. So MF here. So how do we get the MF here? Mass flow of feed equals, just transposing this, no, equals F minus BDM. So what I did is just I put this on the other side, right? So MF equals F minus BDM. So we can um, substitute this here. So F minus BDM. What is F minus BDM? F minus F minus BDM equals F sub M sub F, right? So that is M sub F. We just expand F minus BDM, and this one is percent MF over F. So we just expound this into this kind of expression. So when we have this expression of percent MF, we just have to cross multiply now. So we cross multiply this and this, we cross multiply this and this. The denominator is only 1. So it will retain now F minus BDM. This one is F times percent MF. Yeah, so percent MF times F. This one. Okay? So now we have this equation of percent MF times F, then F minus BDM. As you can see, what could we do? What do we do with this? So we can try to transpose and then rearrange if there are, or if there is common factors. So how do we rearrange and manipulate this equation? So let me use another yeah color so that it will be more clear to us. So we're here, right? We're here. So again, we are trying to get the bone dry mass. So if we are targeting here, all we have to do is to transpose this on the left, and then F will remain, and then this on the right? So let me put that in this, right? So percent MF times F equals F minus BDM. Our interest is this BDM, right? BDM. So I'm gonna transfer this to the other side of the equation. So what will happen is that this BDM, now I'll translate it, then what remains is F equals F, right? And then everything else, F minus BDM, F minus percent MF. So what do we do next? So after this, BDM equals F, then minus, we have to transfer this now. So this we have to transfer on this, so it will become minus. So F minus BDM. right? So BDM will be there, and then F minus percent MF. So this thing here is coming from here, right? So this whole thing here, you have to transfer there, and this negative BDM we have to transfer there. So it's like just an exchange of place. So now we will get the BDM F per minus percent MF, and then as you can see from this simple equation, there is a term that is common. I think you can see, all of you can see that, and that is the F, or the feed mass flow rate of the feed, you know, in kilogram per hour and kilogram per second. So if that is common, so we can say that here, no, so we can put it here, BDM equals what? F, right? That is the common. So in order to get the F, I have to multiply this by 1, and then to get this term, percent M, and then F. So I have to put that in minus, right? So minus percent MF. Okay? So this, because this is a common term, common for this and for this, F minus percent MF, that is BDM. So why is that relevant? So now, if I may rewrite, so BDM is F 1 minus percent MF. Okay, so going back, here is this, right? F, this one. Let me encircle this. So F 1 minus percent MF, meaning the mass flow of the feed is 1 minus percent of the so-called moisture content. Uh, Moisture content. So this is the feed, and this is the product. So same thing will happen in the product. It will become P, quality 1 minus percent MP, or the moisture content. No, because the moisture content is that is something that is you want to remove. Yeah, for example, zero point 0.2 or 0.5, 95%, 0.95 times the kilogram per hour, and that's gonna be equated here, or to put in the equilibrium. So there's a balance between this bone dry mass of the feed coming in and the bone dry mass of the product coming out, right? So same thing with the product. Let me discuss that. Even though we have discussed the feed, let me discuss the product. So the product is like this. Now, if we have a product, it is uh, going to be subdivided into two components, which is the MP, meaning the mass flow rate of the product, and the bone dry mass of the product, right? So that is the composition of the P, which is the product, meaning the product that is coming out at the discharge chute, or the discharge side of the dryer. Now, the product is also called the total mass. So this P is called the total mass. So it's a mass, but totality of mass in the product side. So if we if we are going to to equate P now, so P is like this now. I think it's lacking the subscript here. So P, now this is the P as a whole. P is the summation of M sub P and BDM sub P, right? So if we put that in the equation, P equals M sub P plus BDM sub P. Now, so there are two components of this product. So the one that we just discussed this. Yeah? P equals M sub P. This one, and BDM, right? So here, MP plus BDM. Yeah, so is the mass, and then the VDM. So we just put the subscript P, no? mass flow rate of the product plus bone dry mass of the product equals the product, yeah, coming out of the dryer. So by way of manipulation, you can get the percent moisture. Yeah. How do you get the percent moisture of the product? So percent moisture of the product is the mass flow rate of the product over the total, the product. Yeah, the product total. So here, as what we have done or we did in the feed, so it's like this. Now, percent MP is MP over P. Now, so for example, if we have this mass flow rate of the product as kilogram per hour, then the product here also is the kilogram per hour. No? Then it will be multiplied by 100. So this is just the fraction, meaning the mass flow rate of the product is the you divide this in totality with the product, which is bone, bone dry mass, the bone dry mass plus MP. Okay, so if you equate this, or if you get the ratio of this, the mass flow rate over the totality, then you will have a percent, percent MP, as can be seen here. Okay, so by cross multiplication, or cross multiplication will yield to the equation becoming like a linear. No, P percent MP equals MP. Are you following this? Can you follow this? Percent, this one, this P, just put it here, times percent MP equals MP. Yeah, so here. And then what can you do with this? We have to transpose this, right? So P percent equals MP, then P minus BDM, because we just have to expound some of the terms. So MP, M's MP, not percent MP, but M sub P, meaning the mass flow rate of the product. We can derive it here. No? So how do we derive it here? This one. So mass flow rate of the product equals P, this one, minus, we put this on the other side, minus B dm of P, bundle mass of the product. So here is the MP. So what is MP? P minus BDMP. So this one. So we have to substitute this. We have to substitute this. Yeah. P minus BDMP is this. Now P minus BDMP. So that is MP. You know, so this whole expression here, this whole expression here is just coming from here, which is NP, right? This one. MP is P minus BDM. So P BDM of P. So as you can see, we could get some common. Yeah. So what is the common term there? Let me change the color of the pen so that it will be more visible and more clear to us. So I think you see this, the common term here is the MP, right? This one and this one is common. So all we have to do is rearrange. So we have to rearrange here. I think, sorry, the common is P. let me yeah, I'm a little bit confused. So P is the common and here is the P, right? So all we have to do is this percent MP. What do we do with this percent MP? So first we factor out this. So let me put here. Yeah? So P percent MP equals P minus bone dry mass of P. So here the common is this, right? P and P. So that is the common there, yeah, P and P. So if we want to put that and get the BDN, because our interest is the definition of BDM, a bone dry mass of the product, because that's the critical parameters that we are trying to measure. So BDMP, so if we put that here on the other side, we will be left with P, and then here, this whole thing, P minus P, percent MP. And it's pretty obvious that the common is P. So we take out the common, 1 minus, this one is 1 also, percent MP. Okay? But 1% and percent, right? It's like, uh, is not being put. Yeah, so what we will be left as an equation for us, let me put it here, is BDM, that is 1, BDM equals P, 1, this one, yeah, 1 minus percent MP. Okay, so let me write here. So it will be more clear. Bone dry, bone dry mass is P because there's a common P here, right? P from here, P minus P percent. So P minus quantity 1 minus percent MD. So percent MD. So this one, this equation here is also this one. So we were able to derive BDMP 1 minus percent MD. Okay. So I think that's very clear for now. Yeah. So here is the major equation. BDM P minus 1 minus percent MP, and then when you go to the feed, this one BDM, yeah, because BDM of the feed is equal to the BDM of the product. So in this case, BDM F 1 minus percent MF, yeah. So that is the moisture content of the feed and the product. So that is how it is being related, and how they are becoming related. So there's another parameter that that is always being asked in terms of board exam, and that is the fan capacity. So fan capacity. So let me write here. The fan capacity is this. Yeah, so the volume flow rate at uh, at that point times the mass flow rate at that point, and then here if you're gonna check the units, so volume flow rate is what, the kilometer cube per hour, right? Meter cube per hour, and then mass of air is also different. So mass of air is, let us say, kilogram, yeah, force per hour, right? Per hour, because it's a kilogram, yeah, in the mass, and is the volume. So per hour, no, per hour, meter cube per hour, this the kilogram per hour. So both the r can cancel, meter cube per kilogram. So this is the meter cube per kilogram. So where V is the specific volume, and the M3 M cube is kilogram, and then VA volume flow rate in meter cube per second, and that MA is the mass flow rate. So those are the parameters to be solved, especially on the board exam problems. There are some notes to remember before we proceed to the problem. M sub A. So M sub A is dry air, not humid air. When you talk about M sub A, it is based on the dry air, not the humid air, because the if you get the mass of the humid air, so you have to add still the water vapor content in the air. So what we're talking about here, as far as M sub A is concerned, is based on dry, not the humid air. No? So the humid air has a component of water vapor. Then here it says on the number 2 bullet, the psychrometric chart shall not be used if the pressure is not atmospheric. So it is a common knowledge that all psychrometric chart is based on atmospheric pressure, meaning what is atmospheric pressure? So meaning it is 101.325 kilopascal, then 14.7 psi, 1 atmosphere, and so on. So it is based on the atmospheric condition. Yeah. So this one. So psychrometric chart is based on standard air. Yeah. Meaning 1 atmosphere. Then dry air is it the formula is this, right? So that you will kind of remember. So dry air is total air minus humid air. So if you have seen this, you will infer that the dry air can be found if you multiply the humid, if you deduct the humid air from that. So there's a humid air, there's a total air, so total. Then you get the portion of this, yeah, minus humid, meaning like a moist. So total minus humid, so it will become full of dry air. Okay, so dry air is total air minus humid air, and M sub A, again, I'll repeat for computation purposes, M sub A is, we are considering the dry air there, not the humid air. So another a tool that will help us in the solving of the material under drying is the material balance, of the dryer. Meaning, if you are going to put a box right here, so at this point, so mass of air is coming, then it's going out. Mass flow of air. So that is the rate of air passing or coming into a certain structure. But here, in order to get the energy, yeah, so here we have the mass times specific humidity. So mass times specific humidity. How do we do that? So mass is in kilogram, specific humidity is where? So specific humidity is kilogram of water vapor over kilogram of dry air. Kilogram of dry air. So if you have that, no? So if you have that, you can have the material balance, mass times specific humidity, now coming in. Then this one this one is mass times specific humidity also. No, it's H3. So this one is the feed. Now feed, when it goes down, it is the product, meaning it is less in moisture but high in temperature.
Celebrate Lazada's 5/5 Super Brands Fiesta from May 5 to 9.
So this again is the schematic diagram. Then first the air enters with the heater. So this is the point 1, and then at point 2 it is going to enter in the diagram already. So here is the point 2, right? So you can have the Hg minus Hf. So fan after the heater. So we have here fan. So we have here the fan, and we put that the fan after this one, right? So here is the heater, so we put the fan after the heater, and then it will fan again in the adiabatic dryer. So this is just the reminder of how to manipulate the material balance. So put fan after the heater, and then there's equation here, HFG, meaning H sub F sub G is a mixture of dryness and with the water vapor. So you can have the Hg minus Hf. So the formula, the general formula for this is like this, yeah. So HFG equals Hg minus Hf. But H, no, the enthalpy is H at that point, and then plus X Hfg. Okay? So, dito lang umiikot yung formula ng ganyan sa H plus X HFG. So this X here is the quality of the steam, yeah, and it's also called dryness fraction. So dryness fraction. So this is the formula for the material balance happening in the inside the dryer. So let me clear that. Okay, so here is the psychrometric chart based on SI units, and here is the psychrometric chart based on English. Yeah, so to review you on the psychrometric chart, first it is based on atmospheric pressure, meaning atmospheric condition, meaning 1 atmosphere or 101.325 kilopascal. Now, where is this enthalpy? Enthalpy is somewhere here. When the enthalpy, so here is the the, the psychrometry for English, right? So here is the specific humidity, somewhere here, and then here is also the humidity ratio, which is the same. So this one here is the enthalpy BTU per pound of the dry air, BTU per pound of dry air. So this one, BTU per pound of dry air, and then the others is the relative humidity. Yeah, so this curve here, curve. Yeah, these are the relative humidity. Yeah, so relative humidity. I think this 60, 80, and then 100. Now it's 20 points graduation in the gradient. So 100, 80, 60, 50, 40. Okay. So here in the process analysis on the heater itself, air side meaning the air that is being heated up, the air is being the air that is on the steam side. Now, so it should be that the heat of the dryer will balance this, the air side and the steam side, or the air side, for example, the one that's happening in the air, and also the steam, the one that's happening in the tube of that specific glass side. No? So this is the problem. In a short while, we will take this up. So here are the problems for the dryers that are being considered in the board exam. So we have here board exam given last October 1981. So board exam of mechanical engineering about dryer, continuous dryer in 1981, a long time ago. So if I may read the problem. A continuous dryer is supplied with air, a 21 degrees centigrade dry bulb, and 16 degree centigrade wet bulb, heated to 75 degree centigrade. It enters the heating coils at a velocity of 366 meter per minute, and the size of the circular duct is 183 centimeter. The condition of air leaving the dryer is 43 degrees centigrade dry bulb and 70% relative humidity. The moisture content of the entering material is 24%, while the moisture content of the leaving material is 8%. Now, the question, calculate the amount of moisture evaporated, meaning the amount of water content that is being extracted or evaporated is being asked. Then the capacity of the dryer, we know that the capacity of the dryer is based on the product or the output. Then heat supplied to the dryer. So what is the heat being supplied by the heater to the dryer? So what is our first approach or attack? No, how do we attack? How do we approach the problem so that we can solve this systematically? I think the best way to solve this is to draw the diagram and put all the necessary given, the known data, what are the data available. So I think I have here on the slide.
It's fun. I don't, so ba, pero?
Here. So let us list down one by one the given, right? So we have here a heater that has 21 degrees dry bulb and 16 degrees wet bulb. So where's that? Here. So there's a dryer that has, I mean, in the point one, yeah. At the outside of the dryer, there's a 21 degrees dry bulb and 16 degrees wet bulb. So, as you know, this dry bulb is always higher than the wet bulb unless you are in the saturation point. Now, if you are in the saturation point, the dry bulb and the wet bulb is going to be equal or the same. Then it's heated to 75 degrees centigrade, no, meaning after the heater, it becomes 75 degrees centigrade. No? So let me show you where is that in the diagram or illustration. So here we have the dry bulb, wet bulb, and after the heater, it becomes 75 degrees centigrade now at point 2. So these parameters here are in point 1 before the heater. So there's a mass of air. So also there's a mass of air here. So the dry bulb after the heater is 75 degrees centigrade. I think we are clear on that. And let us continue on the problem. It enters the heating coils at a velocity of 366 meter per minute, and the size of the circular duct is 183 centimeter. So here, what is given is the velocity of the the air, not the velocity of the air that is entering the heating coil, no, with that amount of 366 meter per minute, and the size of the circular duct, meaning there's a ducting, 183 centimeter. The condition of the air leaving the dryer. So where is that? Leaving the dryer. Where is that? Leaving the dryer is what? Here, right? So here is the point 2 entering to the dryer. Then leaving the dryer is this. So it has 43 dry bulb temperature, no? And 70 and what is this? 70% relative humidity. Okay, 70% relative humidity. Okay, so now let me use this so that we can decompose the component. So if this is the dryer, so entering the dryer after the heater, so this is the heater. So after the heater, the temperature is high. Now it's like a 75 degrees centigrade, but the the air before entering the heater coil is 16 degrees centigrade. Now, after the dryer, it is expected that the temperature will a bit go down because you are trying to put or feed some material here. What is this material? Oh, it doesn't say anything about the material, what kind of material, but it will be put in the dryer. So this temperature will a bit go down, and that is expected. And the temperature is 24 degrees centigrade. Okay. So now, how many how many temperature points are we talking about in this problem? How many temperature points are we talking about in this problem? First, from the raw air, yeah, dry 16. Then after the heater, it becomes 75. Then after the dryer, after the material were dried, it becomes it becomes 24. Now, there's another thing that we are going to consider, and that is about the material. So the material in the drying process is called uh, feed and product, right? So meaning um, 75, 43. So here's sorry, 43, 43 degrees centigrade. Okay, I stand corrected. 43 degrees centigrade. Now, about the material. So meaning here there is this material that is coming in. Now, so we call that feed, and there's a material coming out. We call that as product. Yeah. So what do we know about feed? What do we know about feed? It says here the moisture content of the entering material is 24%. So here the percent M moisture, F moisture of the feed is what? 24%. While the moisture content of the leaving, expectedly, it should be less than that of 24 because it's already dried somehow. Now, some portion were dried, some of the water were evaporated. So here, the percent moisture of the product, percent MP, is how much? 8%. Okay. So here is the situation. Now let me draw the psychrometric table in a very fundamental manner. How many points are we talking about here? The temperature of air, we have 16 degrees centigrade. Then we have, it is dried to 75. No? Okay, so from here, so here is the 16 degrees centigrade, this is the 75, no? So if you can see this, no? So this is a dry bulb, another dry bulb. This you can get a lot of things, right? Like this the enthalpy, the specific volume here, the enthalpy and the specific volume here, and here, no? What can you say about the line that is going to from this point? Let us say this point 1 and this point. It is a straight line, meaning for every point that you have in this temperature, this is constant, and this is W, no? 1 or W2 is the same, no? because it's straight line. So W means is SH, specific humidity. The other name for specific humidity is the humidity ratio. Okay? So humidity ratio. So the humidity ratio or the specific humidity is just the same. And the symbol being used in engineering, in mechanical engineering, is W. No? Let us use the W for now. Yeah. So after one and two is the heater, then the dryer, no. So it goes back a bit lower. So meaning here, no, it goes back in a lower form. So it is now becoming like a 43, right? So 43 here, 43. So there are 3 points. 16, now before entering the heater. After the heater, it becomes 75. When you try to feed, try to put the material, that is 24%. And after the dryer, or the drying process, it becomes 8%. So some of the water vapor were extracted, or the water were evaporated. So it becomes, what was that? 43, right? 43. So 16, 75, and 43. So now we are going to take up. Yeah. So here, first we are going to get the points that is given, and then we will try to get the data from the psychrometric chart. Now, before we do that, let us be clear about what is being asked of us. Amount of moisture evaporated, meaning what is the amount of moisture in the material that is being fed, and then after it was dried, how many moisture, no, amount of moisture evaporated, amount of moisture evaporated. So how many moisture or water were being evaporated in this case. Now the of course the unit there is also the flow, no, flow rate, mass flow rate. So let us say it is an kilogram per minute also, or kilogram per hour. Then capacity of the dryer. So the capacity of the dryer is normally in the product. So what is our unit? The capacity of the dryer is in kilowatts, no? Because it's heat. The capacity is in terms of heat, no? So kilowatt, yeah. Then heat supplied to the air, so it's also heat, no? So what is the heat supplied to the air so that it can evaporate that amount, or it can dry that kind of quality, wherein from 24% it becomes 8% of the moisture, right? So first, let us focus here on this thing. Uh, what can we get from this value? First, 21 degrees centigrade and 16 degrees centigrade wet bulb. So meaning 21, then 16 degrees centigrade. Let me draw that so that so if this is our psychrometric chart, pardon me, I'm not yet good in this digital pad. So 16 and 21. No? So let us say that is 21. So 21 degrees centigrade, right? 21 degrees centigrade. But if you get the 21 degrees centigrade dry bulb dB, Then another parameter was given 16 degrees. Yeah. So this wet bulb is always lower than that of dry bulb. So you can have 16 degrees. Now, for example, let me use another yellow color that is yellow so that you can differentiate the lines. No. So if this is the wet bulb in the dry bulb in 21, then the wet bulb is here. No? So here adiabatic saturation. Yeah. So this line is wet bulb and this is what is this? 16 degrees centigrade. This is 21 degrees centigrade. So the meeting point of 16 degrees centigrade and what is this? 21 degrees centigrade. Yeah, 21 degrees centigrade and 16 degree 16 degrees centigrade is this. No, from here you can get things. No, what is this? No, so here you can get things like you can get the enthalpy. Yeah, so here let me put the enthalpy later. No, so here 21 degrees centigrade and the other is in heater. No, because in a psychrometric chart the line going to the rightward to the right is sensible heating, meaning there is happening here there's an increase in temperature, sensible heating. No, so if we increase the temperature because it passes to the heater coils from 21 it becomes 75. So here it is just like straight. No, so let us say that this point is the 75 degrees centigrade. No? From 21, it becomes 75 degrees centigrade. No? So that is heating because it's heater, right? Heating, sensible heating. So here, what can you say about this process? The the straight line will tell us that there are constant or same values happening. No? The specific humidity one, this one, yeah. So 1 and specific humidity 2 is just the same, or SH1 equals SH2. Okay, so that is the or one of the data that we can get. Yeah. So with this portion of psychrometric chart, we can also get the other parameters. Yeah, like this one. No. So the other parameters that we can get is the enthalpy, right? So if you know how to get the enthalpy, you can have that somewhere on this side, yeah, and then you can have this. Yeah. For example, this is the enthalpy line, and this is the other enthalpy line. No, so you can say that this is H1 enthalpy one, and this is the H2 because this is the constant enthalpy lines, meaning all the enthalpies here are the same. All the enthalpies here are the same. Here, all the specific humidities are the same. Yeah. So we can also get other parameters if they are needed, like the specific volume. No. So in this case, we can get the specific volume if we want and if that is needed. Yeah. So we were able to locate this 21 degrees centigrade dry bulb, 16 degrees wet bulb. We can get the enthalpy one there. Then point 2 after the heater. This point 2 is after the point after the heater, or the end of the heater. That is the start of the heater is this in the A, the mass of air, and then it ends in the 2. Yeah. At point 3, 43 degrees dry bulb. So here, look at this. Yeah. So from 21, then it becomes 75, right? 75, and then it goes back to 43. So of course our drawing our drawing of the psychrometry table is not um, based on proper scale. But of course, we could say that it should go back. No, the line should go back because it is lower than that of the the end of the heater. No, the end of the heater, the end of the heater is 75 right here. So this one, all right, the end of the heater is 75 degrees dry bulb. Then at the end of the dryer, the discharge of the dryer is 43. Yes, 20, 70. How do we do this? 20, 30, 40, 50, 60, 70, 75. No, 20, 30, 40, 43. No, somewhere here. So let us say here, yeah, 43. So I'll project, yeah. So let us project. Yes, let us say here. Oh, not yet. We need another parameter, no? So 43. Of course, we know the temperature, that is 43 degrees centigrade. But there's another point that we need, so that we should locate the exact location, and that is the 70% relative humidity. So 70% relative humidity. Let me use another color so that we can differentiate everything. Yeah, right. So here, somewhere here is the middle. Yeah, at the middle, this curve. What is this curve? This is the relative humidity. Let us say 50% relative humidity. So we have to to get the 70. Yeah, so 50, then 60, then 70. Now maybe somewhere here is the 70 and the 43. Yeah, so 43 and 70. Yeah, 43 then 70. Okay, 43 vertical upward, then 70. So this line is 70% relative humidity. So you can have this point here as 3, right? So 1, start of the heater; 2, end of the heater or beginning of the dryer; then 2 to 3. So let me put this black line. So from 2, it travels to 3. Okay? From 2, it travels to 3. So this is the discharge of the dryer, the point 3. The discharge of the dryer with, what is this? 43. No? So let me put this. 43 degrees centigrade and 70% relative humidity. So that is how we locate the points. Now, so now, what do we do with this? No? What do we do with this? We can get the data. So what is W1? W1 is also a specific humidity one. Now, meaning specific humidity one here. Now, so you project this from here, going straight to here. So specific humidity 1 equals specific humidity 2, or W1 is W2. So what is this? 0.009, and the unit is in kilogram because we are in metric, right? So kilogram per kilogram. Kilogram of wet or water divided by the kilogram of dry air. So that's the meaning of specific humidity. So W1 from here is also W2, same. So W1 is W2, like this, right? So as you can see, this one and this one is the same, no? Because W1 is W2, or specific humidity 1 equals specific humidity 2. Okay, now from 1, this point, yeah, this point of 1, yeah, point 1, You can also get the specific volume, 0.846 meter cube per kilogram. You can also get the enthalpy, as I told you, this one, enthalpy 1, then specific volume, specific volume of 1 you can get. So this one is the specific volume, this one is the enthalpy, right? So specific volume. Now, and then 2, when you go to the 2, what is this? The 0.2, you can get the specific volume at 0.2, you can get the enthalpy at 0.2. So this one, now enthalpy at 0.2, then specific volume, let us say here, right? Maybe we can project a line, yeah, like that. So a specific volume at 0.2. Okay, now what about 3? The 3, you can get the specific humidity at 3. Yeah, so let me use another space. Yeah, so here, so that we are clear on this. So here is the psychrometric chart, right? So here is the 21. We were able to locate because we have another wet bulb temperature, which is 16 degrees centigrade, 21 degrees. Then we could get from here the enthalpy and specific volume, right? So we were able to get the enthalpy 1, then the specific volume, of 1. Then here, it is heated up to 75, right? 75 degrees centigrade. No? So here, the specific humidity 1 is equal to specific humidity 2, or the W1 equals W2. Then here, after this, so after this, no, you can get the specific humidity 1 and 2, then the dry bulb 75, and we're good on that. And then it after the operation of the dryer, this is the heater. Then the dryer, after you feed, it will go down a bit. Now from 75, it becomes what? 43. Yeah. So 43. From here, of course, this one at 0.2, you can get the H2, right? H2. That's why we have H2 here, right? And then here at 0.3, you can get the W3 here. Okay? So W3, which is the specific humidity 3. Okay? Now, there are other things that are given here. The velocity of the air going inside the tube of the heater is 366 meter per minute, and also there was a given duct, meaning circular duct. There's a circular duct because this is a square duct, yeah, or trapezoidal duct. Here is the circular, right? Circular duct. The diameter is 183. Yeah, diameter is 183 centimeter. Let me go back to the problem. 183. Yeah, right. So the size of the circular duct is 183, meaning the diameter. Okay. So now, how do we solve the problem? The problem is amount of moisture evaporated, and what is our formula? Yeah, here. So the amount of moisture evaporated or extracted, the amount of water is extracted, is here, no? Mass of the dry air, MA, then specific humidity 3 minus specific humidity 2, no, which is also specific humidity 1, right? So if we rewrite it, mass of air, so that is mass of air then that is W3 minus W2. Yeah. So it's like this, right? So what is our mass of air? Mass of dry air. Do we have mass of dry air? No, yes or no? So mass of dry air as of now we don't have, right? But this is located at point 1, right? So at point 1, we can get the mass of dry air because we have a formula. Uh, because we have a formula here. So mass of dry air is what? This specific what is this? Volume flow rate, right? So mass of dry air, meaning mass of dry air is like kilogram per hour or kilogram per minute, is just the volume flow rate. Now volume flow rate in kilogram per minute. Then this is specific. Uh, this one is what is this? V 0.846 meter cube per kilogram. That is the specific volume at that point. Yeah, this one, right? V1. Okay. So V, no, that is the volume flow rate. Then this is the V at 1. No. So here we can have this, right? So how do we get this volume? How do we get this volume? We have to multiply this by the velocity, no? Area times the velocity, right? Because here is volume flow rate, right? The volume flow rate, which is also the V dot or Q. Now, in other words, they are Q. Q is AV, right? Q equals AV, not the heat, not this the flow rate. Flow rate, QAV, not the Q which is heat. No? So it is in the fluid dynamics. In fluid dynamics, area times velocity, meaning meter square times meter per minute or meter per second, no? Cubic meter per minute. Okay? So that is our point. So let me erase everything so that we can uh, we can uh, be more clear in this, right? So let us use this yellow now. So first we have to compute the flow rate, that in this case this one, right? So here, so this thing here is V equals area times velocity, which is area pi d square over 4, right? Then velocity is 366 meter per minute. Okay, so pi over 4 d. What is d? It was given that 183, right? Square then centimeter square. Okay, so pi over 483 square then centimeter square, right? And then that's the area. So we will have an area, and then we will multiply with the velocity. So area then times velocity, which is what is this? 366, right? 366 meter per minute. Meter, is it meter or what? Meter. Where's that? Oh yeah, 366. 366 meter per minute. Sorry. Yeah, 366 per minute. So there's a problem here because meter and then minute, okay? We have to do something about this. So meter per minute, so this one, right? So we have to convert this into uh, meter. No? So let me put this pi over 483 square, then centimeter square. So here there is 100 centimeter for every 1 meter, right? So if you square this, so you can remove the square centimeter, and then this one is 100 square. Then this is square meter, right? So square meter already. Yeah. So here area times velocity. This will become square meter. The velocity is meter per minute. So our answer would be meter cube per minute. Yeah. So here, assuming that the calculation of this is correct, yeah. So this one is the velocity. Yeah? So this one is the velocity. This one is the area. Area in meter. Yeah, in meter because of this. 100 centimeter, 1 meter, then you both square. Yeah. So you will have a kilogram per minute because the meter and meter will be cancelled, right? So square um, meter, then times meter will become meter cube, right? Meter cube per meter cube there, right? Meter cube, and then meter cube will be cancelled this one. Yeah? So the meter cube here and the meter cube here will be cancelled. Then kilogram will go here in the numerator, and the other one is the minute, right? Here. So it becomes kilogram per minute. So this is the mass. So here is the mass of extracted, no? Ay, not yet. Mass of dry air. We're still in the dry air. So this is the dry air that is entering in point 1. No? So here. No? So here there is a mass of dry air that is equivalent to 1,137.9. Wala. So here there's dry air that is 1,137, no? So 1,137.9 kilogram per minute, right? So that is mass of air. So now, if that is the case, it's not yet complete. So our intention, our solution is this, no? So the mass extracted, the amount of water extracted here is MA, then specific humidity 3 minus specific humidity 2, which is always also equal to SH1. No? So this one, 0.0396, then 0.009. So where's that? Here. So specific humidity 3 so specific humidity 3. So class, I think okay na yon, di ba? Okay na yon. So